Hello everyone. So in this video I will solve problem 13.21. What we have in this question is that we have a mealy sequential circuit which has one input, one output, and two flip-flops, and then the timing diagram of the circuit is given, as you can see, and we want to construct the transition table and the state graph. Okay, so we have to construct the transition table and the state graph. What you have to do here, so you can go directly from the timing diagram to the transition table, but here, since I want to explain how we're doing that, first I'm going to just draw a table, as you can see here, for the information that I can gather for each clock cycle. Okay, and then I'm going to transfer this into the transition table. So as you can see, just by looking at the timing diagram, I saw that whenever we have a falling edge of the clock, one of the states of the flip-flops or both of them, they're changing. Okay, so I said that probably these flip-flops are falling edge triggered. All right, so I just divide this circuit, as you can see, into 9 different cycles of clock. So basically I'm dividing based on the clock cycles. Okay, and now for each clock cycle I'll see how much information I can gather. All right, so for example, for clock cycle number 1 here, what I can see is that Q1, Q2, which is the present state of my two flip-flops, is equal to 0, 0, right? And for the same cycle, you can see that X is equal to 0, which is here. And for the same cycle, we see that Z is equal to 1. What else I can gather here is the next state of the flip-flops. Why am I doing that? Because you know that in the transition table, we need to have the present state, the next state, and the output. Okay? So what is the next state here? So next state means that I have to look after this active edge of the clock. And after the active edge of the clock, you see that Q is equal to 0 here, Q1, and Q2 is equal to 1, right? So the next state is defined as you look after the active edge of the clock. All right, so that would give us 0 and 1. Okay, so this was for clock cycle number 1. Now let's move on to clock cycle number 2. So in the clock cycle number 2, let's see what we have for the states of the Qs. So Q1 is equal to 0 and Q2 is equal to 1, right? So we have 0, 1. What is X during this cycle? So you see that we have 2X. So X is changing twice here, right? First, X is equal to 0. And for that X equal to 0, Z is equal to 0. Then what is changing? X is changing to 1. And when X changes to 1, Z is changing to 1, right? So note that the state of the flip-flops are not changing in a clock between two clock cycles. As you know, state of the flip-flops only changes when the active edge of the clock happens. All right? Only it is the output which is depending on the input as well. All right? So when the input is changing between one clock cycle, then the output is changing. All right? And this was the specification of the mealy circuit, right? The output was both depending on the states of the flip-flops and the input. Then what else we need? We need to find the next state of my flip-flops. Let's look at here. So we have to look from this point to the right, which is the next state of my flip-flops. And you can see that clearly it is 1, 1, right? All right, let's move to the third one. So in the third one, the present state of the flip-flop is equal to 1, 1, right? So see, you don't, actually for example, clock cycle number 2, the next state would be equal to the present state of the next cycle, right? Okay, so what is happening with X here? So again, you see that in clock cycle number 3, X is changing once. So when X was equal to 1, Z was equal to 1 as well, right? And then X is changing. So X is changing to 0 and Z is changing to 0 because of that, right? Oh, changes to 0, I wrote 1. Then the next state of my flip-flops is we will look at here at this point, okay? And the next state of the flip-flop is 1, 0, right? Okay, for clock cycle number 4, we know that for clock cycle number 4 that we're looking here, the present state would be equal to the next state of the previous cycle. So 1, 0, correct? And then let's see what is happening with X. So again, X is changing here. So first X was equal to 0 and Z was equal to 1. Then X changes to 1. And what is happening with Z? Z is changing to 0, right? So the next state of my flip-flops, Q1 plus and Q2 plus, is when we look at this point to the right. So at this point to the right, we have 0, 0, 0, 0, right? Okay, so this was the 4th cycle. Q2. All right, so now we go to the 5th cycle. So in the 5th cycle, Q1, Q2 is equal to 0, 0, right? Then X is not changing in this cycle, so X is always 0 and Z is also equal to 0. What is the next states of my flip-flops? We can see that at the beginning of the cycle 6, the states of the flip-flops are 1, 0, so my next states is 1, 0. Then we go to the 6th cycle, so Q1, Q2. So the present state of this cycle will be equal to the next state of the previous cycle, right? So 1, 0. Let's see if X is changing. Yes, in cycle 6, X is changing once. So when X was equal to 1, Z was equal to 0. And when X changes to 0, Z is equal to 1. Okay? And then Q1 plus Q2 plus, the next states of my flip-flops are equal to 1, 1. All right, so now I will move to 7th cycle. So Q1, Q2 is equal to, so the present state of the 7th cycle is 1, 1. Then for X equal to, so here as well, X is changing once. So first X was 0, Z was 0. Then X goes to 1 and Z goes to 1 as well. Okay, and then the next state of my flip-flop here, we look at the beginning of clock cycle 8. So you see that it is 0, 1. Okay, then we go to the 8th cycle. So Q1, Q2 at the 8th cycle, which is here, is equal to 0, 1. And then in the 8th cycle, X is also changing in between. So X was equal to 1 at the beginning of the cycle, and Z was also equal to 1, right? Then X changes to 0. So actually here I should put this. Okay, X changes to 0. So Z is also changing to 0, right? And then the next state of my flip-flops is 0, 0, right? And then I will just write this because I said that in this table, I'm going to gather as much information as I can. So I have a part of cycle 9 here in this timing diagram. So Q1, Q2 are equal to 0, and I know that X is equal to 0 and Z is equal to 1. So this is as much information as I could gather from this timing diagram. Okay, so we found the present state of the flip-flops. I found what are the outputs with respect to the inputs, and also the next states of the flip-flops. So I will stop this video here, and then I will continue in the next video and transfer this table information gathered to a transition table, and also we will draw the state graph. All right, see you in the next video.